Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest's Sciences and Mathematics TV channel. So today we're going to look at the concept of continuity of functions. And first, before I continue, I'd like to appreciate our members, our new members who have already joined and the members who are already on board. And I'd like to request us to kindly go to YouTube, check Sciences and Mathematics, engage us in the comment section, and also subscribe to our channel to be getting updates on our various topics that we discuss in mathematics, physics, chemistry, and biology. So today we're going to look at the concept of continuity of functions. And this, of course, is going to derive some of the concepts that we have already done from the aspect of limit from our last discussion on the concept of limit. So we are going to use a graphical representation to try and show what this aspect of continuity basically refer to. And of course, in this case, I'm going to use a set of 4 graphs, which are going to assist us, of course, define what this aspect of continuity is insofar as the functions are concerned. So on the board, I have a set of 4 graphs, or rather 4 axes, for illustration. Let me give them as A, B, C, and D. And this is going to assist me, of course, try to differentiate between the aspect of a function that is can be regarded as continuous and non-continuous. So in this case, I'm going to use the first one to illustrate a function. This specific point at this value. So I'm going to give the coordinates of this as a and a function over a. It's going to be given as such. So this is the coordinate over this specific point. So this point as well can be given using this specific case. So whenever I'm going to circle this one, it implies that this point of a function is an integral part of this specific function. And this one, of course, we're going to see that this specific point, we're going to have this one, of course, not being defined. So therefore, it's going to be existing in terms of a small circle, which is open. So in this case, I'm going to use the concept of a drawing, or rather a drawing whereby if I'm writing this specific function as such, I'll have to lift my marker pen, and then I'll have to draw that circle and give it as such. So this is going to depict the aspect of continuity, unlike a case whereby I'm going to draw like this and then continue. So in this case, I have to reach at this specific point, raise up my pen and draw this. So this is going to depict the aspect of a continuity, while this one is going to be depict an aspect of discontinuity at this specific point. So therefore, for the first graph, we are going to see that it consists of functions that consist of 2 parts. This specific value for a, we are going to see that this particular function is going to be discontinuous, whereby we are going to have this particular break of this set of graph solving, so showing a continuation, but this second part of it showing some gap in between. So for the second function for b as well, it's going to show some aspect of discontinuity. And also for the third one, I can have an example of a function that perhaps is a curve, and it's going to be given in that specific respect as well, using that one and having a break. So if I draw another function without lifting my pen and then having this specific aspect of a solid point, then these 2 specific aspects depict the aspect of continuity, in a sense that if I can take it literally, then therefore I'm not going to lift my marker pen before I continue with that. And then in this case, I have to lift it in order to continue with that line. So this one, of course, is going to give us a rough illustration of this aspect of continuity. Now, for the graphical illustrations that I've given on the board, then therefore this is going to, of course, give us a clue whether the aspect of limits that we are defining in our first case basically are going to exist or not. And we said that the limit basically is a value of that specific function at that range of the interval. Perhaps for a and b, the value of a function at a, or as it approaches a, then therefore it's going to be the value for that specific limit. Now, if you try to analyze, then therefore we're going to see that for the first graph that I've given for a, it is going to portray some aspect in a sense that this specific function is not going to be continuous due to this particular break. And this particular holes which are found in between where I lifted my pen, of course, are going to depict that these 2 functions as well for c and b and c are not going to be continuous. But this one that I held my pen and drew continuously, of course, is going to be an aspect of continuous function. So for the first one, the limit for that function is not going to exist at this point whereby x is equivalent to a, due to this particular aspect of the graph that I've already explained for a. So for b as well, we're going to see that for b the limit is going to exist, but the function is not going to be defined at the point of x is equivalent to a. As I said, there's going to be a gap that is going to be experienced at that particular point. And for this specific case for c, we are going to see that the limit is going to exist, but it's not going to be equivalent to the value of a function at this particular point, x is equals a. So as we said, the limit of a function is the value of that function at that specific point. So this is going to violate that specific rule. And then we're going to see that for the last case, the limit is going to exist since this point is an integral part of that particular function. And therefore, we're going to regard a point as c, of course, or the graph for d as a continuous function, which is going to be distinct from this set of three functions that I've given on the board. So in this case, of course, we can be able to generally, or in a summary formula, distinguish the graph of d from the rest of this, in a sense that it's going to be continuous due to its unique nature of having this particular point as an integral part of this specific point. And of course, its limit is going to be defined at this specific point. And for this one, the limit is not going to be existing at this specific point, since the value of x is not going to be the value of that specific function at this point of x is equivalent to a given as such. So therefore, this is how we can be able to graphically analyze and represent the concept of a continuity. And we're going to also to find this one being heavily defined in various aspects of our calculus that we're going to learn, whereby we're going to consider the various aspects of a function, especially which are continuous, and characteristics of those specific functions being given in a specific way. So of course, this is going to be applicable in collaboration with other videos. I'm going to put a link of the description box of a link of various videos in terms of playlist. Kindly check and also engage us in the comment section so that we can be able to assist one another in discussing this particular concept. So that is it for now, guys. Bye. God bless you.